If n is an odd integer, then evaluate integral 0 to pi x sine nx by sine x. Now this is also a very important application of definite integration. The procedure we follow, understand that very carefully. Let's treat in to be the integral which we need to evaluate, that is integral 0 to pi x times sine nx by sine x dx. Now this integral can be re-expressed as integral 0 to pi minus x times sine n times pi minus x by sine of pi minus x dx, which is integral 0 to pi. Let's split with the first function pi. Then it is pi times sine nx by sine x dx minus integral 0 to pi with the second part, it is x times sine nx by sine x dx. Now if you observe, the second part is back to I again. So this is nothing but, now this value being I, what is 2i now? When we bring the minus side to right hand side, we get 2i as integral 0 to pi times sine nx by sine x dx. Now we are able to eliminate the x which is outside the sine x function in this integral. So now the calculating of in which we need is the pi by 2 times integral 0 to pi sine nx by sine x dx. We need to evaluate this integral. Now we are also given that n is an odd number. So n must be in the form 2m plus or minus 1, where m is an integer. So using the relation that we got as in is pi by 2 times integral 0 to pi sine nx by sine x dx, let's define im. What is im now? It is pi by 2 times integral 0 to pi sine of 2m minus 1 times x by sine x dx, and let's define im plus 1. Then im plus 1 is in pi by 2 constant 0 to pi sine of 2m plus 1 times x by sine x dx, right? As n is fixed to be an odd number, we took im and im plus 1, so that one is with 2m plus 1 and the other one odd number is 2m minus 1. So what is im plus 1 minus im, that is two consecutive odd integers are considered, then pi by 2 which is constant in both, and both the integration limits are same 0 to pi, then the numerators become sine 2m plus 1x minus sine 2m minus 1x by sine x dx. Now we can apply transformations on the numerator. This is integral 0 to pi. How will be the transformations on the numerator? This is 2 times cos 2mx into sin x by sin x dx. Now the sin x in both the numerator and denominator cancels, leaving us with pi by 2 times integral 0 to pi 2 times cos 2mx dx. What is this value? This is pi times the integral of cos 2mx is sin 2mx by 2m, and the value of integral evaluated between 0 to pi, that is upper limit 0 and the lower limit also 0. Now we got a very important and interesting result here. Im plus 1 minus im is coming to be 0. So what do we conclude on this? We get im plus 1 is equal to im. Now if im plus 1 is equal to im for all m being a natural number, then can we conclude that I1 should be equal to I2, should be equal to I3, should be equal to every of these values should be equal, and we need in value. So can we calculate in terms of I1? What is I1 then? Integral 0 to pi sine, yes, 1x, that is sine x by sine x dx. So it would be integral 1 dx pi minus 0. So how much is into pi by 2? So this is pi by 2 times integral 1, that is pi. So how much is this value coming? It is pi square by 2. So how much is the value of in? The value of in which we wanted to calculate is pi square by 2, which is present at option B in the given choices, right? And another important method of finding the definite integrals using reduction systems.